Welcome to another Math Ninja Pro video.
In this video, we are going to see how we can use the zero factor theorem to help us solve more difficult quadratic equations. In order to solve quadratic equations using the zero factor theorem, we will need to have a times b equals to 0. In other words, we need to have something times something equals to 0. In other words, a product of factors equal to 0. So if we look at the first equation that we need to solve, 2x squared plus 16x equal to 0, it certainly does not look like this form where we have something times something equals to 0. So in order to get it into this form, where we have something times something equals to 0, we will need to factorize this expression on the left, which is 2x squared plus 16x. So can you see that 2x squared plus 16x actually has a common factor of 2x. So if I extract 2x as my common factor, I will be left with x plus 8. Right? So now can you see that we have our a times our b equals to 0. So in other words, if I were to solve this, I would have 2x equal to 0 or x plus 8 equals to 0. So in order to solve for x, I simply divide by 2 on both sides, so x equal to 0, or here I will need to subtract 8 on both sides, so x equals to negative 8. Let's look at the second equation, y squared plus 3y plus 2 equals to 0. So again, in order to get it into the form of something times something equal to 0, I will need to factorize. And since y squared plus 3y plus 2 does not have any common factor, I would need to use the multiplication frame method to factorize. So in order to use the multiplication frame method, let's fill in our y squared term in the yellow box and the constant term in the pink box. And then let's guess our factors. So we have y times y, which is equal to y squared, and 2 times 1, which is equal to 2. So in our first grey box, we would have 2 times y, which is 2y, and 1 times y, which is y. So if we check the grey boxes, 2y plus y would give us our 3y. So therefore, our factors must be y plus 2 and y plus 1. So let's write that down, y plus 2 and y plus 1. So here we have our a times b equals to 0. So either a equals to 0 or b equals to 0. So therefore my y would be equals to negative 2 or y equals to negative 1. Alright, let's move on to the third equation. So in the third equation, alright, it looks like we would need to use our multiplication frame method again. We have 50p squared, 140p, and 98. If you look at the coefficients, the numbers are really big. If we are going to use multiplication frame, we are going to take a long time to guess and check the factors. But do you notice that 50, 140, and 98 have a common factor of 2? So let's try to divide throughout by 2. This means that we divide every single term in this equation by 2. So 50p squared, if you divide it by 2, you get 25p squared. 140p, you divide by 2, you get 70p. 98 divided by 2, you get 49. Now when you do this, do you notice that 25p squared can actually be rewritten as 5p squared? 49 can be rewritten as 7 squared. So now this looks a little bit like something that we have learned previously, which is our special algebraic identities. A squared plus 2ab plus b squared, which can be factorized to a plus b whole thing squared, right? So let's check. Alright, if our 2ab is indeed equal to 70p, so if we rewrite this part as 2, the a is 5p and the b is 7. Now let's multiply this and check. 2 times 5p is 10p. 10p times 7, alright, is going to give us 70p. So therefore, we have actually rewritten this successfully in the form of a squared plus 2ab plus b squared. So in other words, we can factorize it to a plus b whole thing squared, where the a is 5p and the b is 7. So if I have a plus b bracket squared equals to 0, this means that a is equal to 0, right? I mean the 5p plus 7 is equal to 0, right? So let's think about it in this manner. If x squared is 0, obviously x has to be 0. So it's using the same idea. If 5p plus 7 bracket squared equals to 0, 5p plus 7 must be equal to 0. So how can we solve and find the answer for p? We simply need to first subtract 7 on both sides. That will give us 5p equals to negative 7. And then in order for us to find p, we divide by 5 on both sides. So p will be negative 7 over 5. Or I can write it as mixed numbers, negative 1 and 2/5. That would be my solution for this equation. So you can see here that in general, quadratic equations have two solutions, but there are occasions when the quadratic equation can actually just have one solution. Okay, now let's move on to one last example. I have 121 minus 4h squared. Now can you see that this equation that I need to solve is very similar in form to a squared minus b squared on the left hand side, and this can be factorized to a plus b times a minus b, right? So I can actually solve this by rewriting 121 as 11 squared and 4h squared as 2h bracket squared equals to 0. So this is my a squared and this is my b squared. So I'm going to factorize it to a plus b and a minus b equals to 0. So in order to solve this, I would have 11 plus 2h equal to 0 or 11 minus 2h equals to 0. So in order to solve this, I would have 2h equals to negative 11 and then dividing by 2 on both sides, h would be negative 11 over 2 or negative 5.5. And here I can also solve this quite easily, and I would get h to be equal to positive 5.5. Alright, so this is one way of solving this equation. Another way of solving this equation, right, let me rewrite it here, is to think of it as solving for 4h squared first. So 4h squared is actually 121. So what is h squared? h squared will be 121 divided by 4. So how can I find h? h will be the positive and negative square root of 121 over 4. So if I were to square root 121, I will get 11. I square root 4, I will get 2. So I'm going to get positive and negative 11 over 2. So that is the positive and negative 5.5. So again, you can see here in this last example, we have two solutions. H equals to positive and negative 5.5. Right, whichever method you use to solve.
Remember to like, subscribe, and keep coming back for more Ninja level math videos.